Hello everyone, today we will focus on the linear regressions of practical implementation. Uh, First thing first is basically we will import the pandas. We are planning to use Boston datasets, which is basically a house pricing datasets. We are bringing it from the sklearn datasets. We have we are bringing NumPy, Matplotlib packages, and then we are just loading the data into a DF. Okay, cool. So up to this, it's very easy, very simple, nothing special I'm doing. Only thing, like if you can see, the data is actually in the array format, target variable is also in the array format, feature names are available here. So what we are doing in the next step, basically just creating a data sets, converting this data into a data frame. So now you can see it's a data frame because it's a pandas data frame. So the data set looks like this, but we do not like this. We don't want this just 1 2 3 4 number. We want this with a name. So that's why we are bringing the feature names, because these feature names are available here. So we just need to bring those feature names and then we can use that as a head. What we are planning to do, the target variable is also we are adding into this. So finally our data set is looking something like this, where we have all these different features which we will use for model prediction, model training, and this is our final target variables. Okay, now what we are doing, we are splitting these data sets, again these data sets, into two parts. This is basically my independent features and this is basically my dependent features. It's basically just keeping the last feature, which is the price, and here it is keeping all the other features. So the y component is something looking like this, like 24.0, 21.6 or something like this. Next important part is the train test split. So the entire data sets we are dividing into two parts, train and test. So it will have a xtrain component, xtext component, y train and y test component. We are passing the x and y. Test size 30 means 70% of data will be used for training and 30% will be used for test. Random state 42 means every time when we will run, this distribution will be same. Okay, so how our xtrain looks like now? Xtrain looks like this, which is exactly same like this, only thing the price is not available here. Okay, and we can see that we have this many number of rows, this many number of columns. So this is only the 70% of this. Okay, there is another way, I think, if you can do jobs by shape, so you can do it very easily. And if you want to test the x test part, that is also possible. Okay, 152 records are there. Now we are using this standardizing the data sets. This is something I don't want you to remember anything. So basically standard scaler is, especially whatever algorithms we are using, we have a gradient descent. It's a best practice to convert them into a standardized form. The data will be standardized. So that's the reason we are bringing the standard scalar package, and then we are fitting it for xtrain and we are fitting it for xtest also. Okay, up to this nothing special, everything is very simple. Now you are bringing this linear regression package from the linear model. As I mentioned, this is again part of this linear model. So inside this we have that linear models available, so you can have a look when you have a time. And also we are bringing two more important things, that is cross-val score and cross-validation, cross-validate. Okay. Now, what's the basic difference between these two? Again, I provided all the links here. You can check cross-val score and basically what it is doing. But the basic difference between this is it will split your data, split your train data, because it will use your train data, and we will use the cross validate, because cross validate can take multiple metrics, whereas cross val score take only one metric. So I personally like the cross validate option better than the cross val score. But if your requirement is only to use one of the metrics, then you can absolutely go with the cross val score. I do not have that much data, that's why I use 20, but normal convention is either 5 or 10, so I will stick to 5 for the time being. And we will basically, what we are doing, we are passing the model, we are passing the X train and Y train, and we are passing the metrics, and also we are passing the CV equal to 5, which is telling how many splits will happen on this data, and that's 5 split will happen. That's mean if I run this, it will run actually 5 different types, and it will produce 5 different results. This is in a dictionary format, and this is a little difficult to read. That's why I'm converting into a data frame. And then this data frame will tell us, okay, it ran 5 times, and 5 times, what is the fit time, what is the score time, and every time what is the negative mean absolute error, what is the R square error, what is the negative root mean square error. And then we're capturing that information from this list just to calculate the mean of these values. So finally we got the mean of these values, and these means are, especially for R square, our expectation is as much as it's go higher, so that is good. For negative mean absolute error and negative root mean square, as close it will go down, that is good actually. So in this case we are getting like this. Then we are using X test for our test, which is for the prediction. And once this prediction is done, then we want to validate how it looks like. So we'll create this graph, and it is telling us that our variance is not that much comparing to our prediction and test, because this is kind of a bell curve. So this is good, and because we are doing it on the standardized data, that's why it's on the right hand side, little bit on the graph. Okay. Also, there is another way we can measure how the R2 score is coming on the test data, which is coming 669, which is a good sign, because that's mean my test result, which is 66.66, and here also it's 0.68, not a significant difference. That's mean there is no over prediction or overfitting is at this moment. And also we can do the graphical representation of our presentations. It is giving the scatter plot using the y-test, and this is giving that indication how our prediction works. So it's kind of looking good at this moment. So this is the first round, and hopefully you like it. If you like, please subscribe and like the channel. I'm still trying to grow. I'll provide my email ID by chance if you need any help. I'm ready to help. I'm also learning the data science world, so we can learn together. Any question, let me know. Thank you. Have a nice day. Bye.